Okay, well now it's time to see how all that preliminary stuff fits together. And let's solve a problem. This is a pretty easy one by comparison. Y prime plus y equals e to the minus x with the initial condition that y at 0 equals to 1. Okay, now I think by now you could probably think of several ways to solve this problem. And but let's look at Laplace transform method. So I'm going to start off, and here's where you get to see everything come together on this. I'm going to start off by taking the Laplace transform of the entire equation. Y prime plus y equals to e to the minus x. Now, because the Laplace transform is a linear operator, very advantageous, that means that we can break this up into separate pieces. L operating on y prime plus L operating on y equals to L operating on e to the minus x. Okay, now then, L of y prime is, I think it's S, I want to look that up to make sure I don't get my signs backwards. It's S L of y, okay, minus y at 0. Then, I'm going to need my book handy here in a moment, plus L of y equals to the Laplace transform of e to the minus x, and I'm going to look that one up. Page 306 I think is the short table. So this is the third line down on the table that I'm looking at, where a is negative 1. So this is the Laplace transform of e to the negative x is going to be 1 over s plus 1. Alright, we'll need that. Now then, I'm basically going to solve for the Laplace transform of y. But we can plug in 1 here because y at 0 is equal to 1. So I'm going to add 1 to the right side and factor out the Laplace transform. So on the left side, I'm going to have s plus 1 times Laplace transform of y. On the right side, I'll have 1 over s plus 1 plus 1. So I added this minus 1, I added 1 to the right side, and I factored the Laplace transform out, leaving s plus 1. And so now the Laplace transform of y is equal to, I'll divide by s plus 1, and we get 1 over s plus 1 squared plus 1 over s plus 1. I think I'll keep it in that form. We could combine fractions here. That would be okay. But if I divide both sides by 1 over s plus 1, over here I get a second power. Here I get 1 over s plus 1. Alright, well, we come to the crucial moment. Now what do? And at this point we take the inverse operator. Okay? And so that table we built up gave the Laplace transforms, but it also tells you what the inverse operators are. And so the inverse operator operating on the Laplace transform of y in this problem will be the inverse operator operating on 1 over s plus 1 squared plus 1 over s plus 1. Okay, now these cancel, literally they cancel, and so y, we solve for y. Y will be this problem. Now it turns out the inverse operator is also a linear operator. Okay, the inverse Laplace transform operator is a linear operator in its own right. That means I can break this up. And so I have the inverse operator on 1 over s plus 1 squared plus the inverse operator operating on 1 over s plus 1. So now it's a matter of looking up the answers from the table. So if we look in the table for 1 over s plus 1 squared, and that would be associated with the sine function. So because the linear operator, the Laplace transform of sine ax is equal to a over s squared plus a squared. Well, if a is equal to 1, the Laplace transform of sine x will be 1 over s squared plus 1. Oops, I picked the wrong one. Let me see, I need to use, oh, well, 2 lines down from that. Okay, why doesn't that work? Because I need s plus 1 parentheses squared. Oops. Alright, so I don't mind making that error, because, gosh, I think students sometimes make errors, and gotta be careful. So, let's try this again. I think the one we need is the Laplace transform for x sine ax, because it shows up as 2as over s squared. Oh, nope. That's not right either, is it? Well, I tell you what, I've really botched this. That one's not going to work either. You can look carefully to see why. All right, we'll try this a third time. Third time's the charm. And I see it now. It's the expression for x to the n e to the ax. So, all right, one more time. Laplace transform of x to the n e a to the x. According to the book, this is n factorial over s minus a to the n plus 1. Now, I think if you use Laplace transforms a lot, this would be just easy. Okay, you'll be used to these. Yeah, I only use these when I teach it. All right, so a is going to be -1, because s minus -1 would be the same as s plus 1. So a is -1. And I need 2 to equal to n plus 1. That means n equals to 1. And n factorial is also 1. So the Laplace transform on x to the first power times e to the negative x, a is -1, would be 1 factorial over s plus 1 squared. All right. So the let me erase this. That means that x e to the minus x would equal to the inverse operator on 1 over s plus 1 squared. There we go, and here it is. So that means that this expression here is simply x e to the minus x. All that work for that. So let me erase most of this. Now the other one to look up is 1 over s plus 1. And the Laplace transform on 1 over s minus a is equal to e to the ax. So a would be -1 here to get that cancellation of signs. And so this would be literally the Laplace transform of 1 over s plus 1 would be e to the minus x, -1 times x. So plus e to the minus x. All right, so I think we have an answer for this problem. Y equals to x e to the minus x plus e to the minus x. And that could be simplify it, I suppose, factor out the e to the minus x, we have x plus 1. So I want to double check that and make sure we're okay. I'm feeling pretty confident about this problem. Now where are those problems? The problems are on page 311, in case you're wondering. This was problem 14 on page 311. And the answer is going to be x plus 1 times e to the minus x. There we go. Got it correct. So I'll do another one or two of these, and then we'll take a quick look at the gamma function.